Assalamu alaikum everyone. Guys, today I am going to present my project on image compression using singular value decomposition, also called SVD. This project is built using the most popular library in Python, which is called NumPy, and for GUI interface I used CustomTkinter library. Before going to its details, first of all I give little bit background of my project, that what's real problem of user solves it. We can, in real life, we as a user take a lot of images or pictures in our daily life in the form of selfies, in the form of pictures, or etc etc. So I give a detail about that. What is an image? Image are basically large matrices of pixel values. Because of this, they take a lot of storage space in our mobile phone or in our computer, in our PCs, when our pictures are highly qualitative. So my project goal is to reduce the size of the image while preserving its important structure. So what is an SVD? For compression, I am using SVD, which decomposes an image matrix into three parts. Instead of storing full data, we keep only the most important components of an image in it. So let's move towards it. Here I upload an image from my disk. Yes, it is converted into a NumPy array in the background, which means that it becomes a matrix of numbers. The left side slider controls the value of k. Basically, k decides how many important features of our image we want to keep. Low k means more compression, and high k means better quality but less compression. On the left side, guys, on the left side is my original image, and if you see on the right panel, it is the compressed image. You can clearly see how details are reduced when k value is low. So when I load the value of k, decrease the value of k at the right side of my image, guys, you can clearly see that my image become more blur and blur. And when I further slowly increase the value of k, and increases, my image become more clear with the increase in the value of k. So my project goes with the idea of compression, that how an image is compressed. Let's take another example from my PCs, the pic of Cristiano Ronaldo. So here we can apply compression as well through my project. So when we increase similarly the value of k, the image goes to its original picture and it becomes clearer and clearer and clear. And when I decrease the value of k, so guys, you can clearly see that the image becomes blur and blur with the decrease in the value of k. Here we can also, if you look at the statistics channel, here we can also calculate compression statistics, including optional size, compression size, and percentage reduction. The stats channel also show us full stats of how our project works, that our original size photo is this, how much it's compressed, and its reduction size, and also show us the value of k along with the zoom option button in it. So in data science, we often deal with high dimension data, just like in images, which are large matrices. So SVD is a technique used to reduce this dimension while preserving its important information. I give you an example from the real life. In real industries, applications like Facebook or WhatsApp, data is huge, like images, videos, or user data. So SVD helps in reducing storage, improving speed, and removing our noise. So as a data scientist, this project helps me to understand how raw data is transformed into meaningful patterns. It builds intuition for how many machines extract important features from the data. So if we move towards its code, mm, Yes, this is my original code. So basically, I use NumPy 3 basically concepts in this my code. The first one is array slicing. What is array slicing? Array slicing, I give a little bit introduction about array slicing in it. Array slicing is a NumPy technique used to access a specific portion of an array without copying the entire data. So in my project, this code snippet gives us information about array slicing. In my project, array slicing is used to separate the RGB channels of an image. Since an image is stored as a three-dimensional array, I used explicit. Explicit meaning extract the red, green, and blue channels individually before applying SVD in it. After the array slicing concept, I used reshaping concept in it. Reshaping concept, I little bit give introduction about reshaping concept. Reshaping is the process of changing the dimensions of an array while keeping the same underlying data in it. So in my project, in this code snippet, I uses the concept of reshaping. Although reshaping function is not directly used in my project, the concept of reshaping appears when the compressed RGB channels are combined back into three-dimensional image using np.stack. And the third, and which is most important function I used in my project, which is U functions. U functions are optimized NumPy functions that perform element-wise operations on arrays. So that is my whole project about compression. Thank you so much.